Okay, this is advanced math homework questions from lesson 8.3, and these are the 4 problems I'm going over, starting with number 60, which is f of x equals the 4th root of x squared plus 3x. All right, I'm going to tell you right now that this is one of the most missed on the test. And it's because people just flat out forget this, what's going on here and how to treat it a little different than other problems. Is everyone ready?
Yes.
Okay. First off, is that an even index or odd?
Even.
An even, is there restrictions?
Yes.
And what's the restriction? The inside has to be positive, which means greater than or equal to 0. Okay. So x squared plus 3x is greater than equal to 0. Did any of you get this far already and write this down on your own? Yes. Did anybody get as far as this? Yes? Now, if you didn't get this far on your own, does it make sense now that you see it? Those of you that were working at it already, did any of you do this? So don't do that. Did you do it, anybody? If you did not, please do not make that mistake. I only pointed out because that's like the biggest mistake kids make on this type of problem. You do not do that. You do not. If it equaled 0, can you set them both equal to 0 and solve? Yes. Now, I will tell you this. It is a test value type problem where we do our little plus minus chart. Now, how do you know when it's a test value? Here's what has to happen at the same time. There has to be an inequality. Doesn't matter if it's greater than, less than, or greater than equal to. Any inequality, and the degree is 2 or bigger. So x squared, x cubed, x to the 7th. The degree is 2 or larger, and there is an inequality at the same time. It is a test value type problem. So, first off, if I had something like this, x plus 3 is greater than equal to 0, would that be a test value type problem? There's an inequality, but there's no what? What's the degree here? There's no x squared or x cubed. It's just x to the first. This you would just subtract 3 and be done. What if I had x squared plus 3x equals 0? Would that be a test value problem? No, because there's no inequality. There's an equal sign. You just factor and solve. Do you see the difference between these two and the one we're dealing with right now? Okay. Steps. We had the steps in our notes the other day. Step 1 was to find your what? Find your zeros. What are my 2 zeros? X equals 0 and then step 2, we plot those on a number line. -3, 0. I look up right here to see if it's closed or open. What is it? Closed. And what am I looking for, by the way? Positive numbers or negative numbers, according to this inequality? Positive, which makes sense because it's underneath the 4th root. All right, now we pick our test values. Something to the left of -3. Would -4 work? Yeah. Would -10 work? Would -2 work? Not for my first test value. Put your phones away, please. Now, I like picking 0 when I can. Can I pick 0 in this case? No, I don't pick my test value, my actual zeros. So give me a number between -3 and 0. -2. Would -1 work? All right, now to the right of 0, give me a value. 1. Would 1.5 work? Even 0.5. Okay, so you're going to plug it in right here and check to see if it's positive or negative. I'm going to put this x in a parentheses just so it's easier to see down here when we do our test values. All right, when we plug in a -4 and -4 plus 3. -4 by itself, that's it, just -4. Is that positive or negative? What about -4 plus 3? Positive or negative? And 2 negatives, when you multiply, make a positive. All right. Next thing I'm going to do is plug in what number? The -2. So -2 in parentheses and the -2 plus 3. All right, negative 2 by itself is positive or negative? Negative. What about negative 2 plus 3? And that makes a... All right, and then the last one we plug in is what? The 1. 1 by itself, positive or negative? Positive. And then the next piece is 1 plus 3. Is that positive or negative? Also positive, and that multiplies to a positive. Now, where did we say earlier we wanted to shade? If it's greater than equal to, or is that the positive or the negative? Positive. So I'm going to shade on the outside. Does that make sense? Interval notation, negative infinity to negative 3. Bracket on the negative 3 only because it was a closed circle. Union 0 to infinity with the bracket on the 0. Closed circle, and again, that's because there was an equal bar there. Any questions on that one? Yes? Oh, how do you know? Good question. Can anyone answer that? Her question was, do we always shade the positive, or how do we know? If this, it wouldn't be with the fourth root problem, but just say it wasn't that, they just gave you this, but they wrote it this way, what would you be shading? The negatives. So it depends on what's there. We had to write it greater than equal to because we're dealing with a restriction type problem. But if they wrote it for you and it was less than equal to, you would shade the negatives. Does that make sense? Are we good? Okay. 61. G of x equals 1 over x minus 3 over x plus 2. Anybody know what the common denominator would be? X and x plus 2. Do we all agree with that? Is there any square roots at the top? No. So when I find my common denominator, do I really care what ends up being at the top? Yes or no? No. I don't really care what's up here. Because there's no square roots, I just look at the denominators. They're both the same, so x and x plus 2 cannot equal 0. What are my two restrictions? X cannot equal 0 and x cannot equal what? Negative 2. And you write that in interval notation. You either can look at it and you know. If you don't remember, then you do this, because this will always help you. Cannot equal, so those two are open, and everything else is shaded. I shade everywhere except for the two numbers that it cannot equal. 0 and negative 2 are the only two x values that will make this expression here undefined. Function, because it is g of x. So we'll make this function undefined. So how do you write that? Do you guys know how to write that in interval notation? Am I shaded in here as well? Yes. So negative 2, 0, union. All right. And I put parentheses on the 0, negative 2, again, because they're open. And the infinities always have parentheses. Questions on 61? Are we good? Yes?
You didn't have to do the chart for the see which was negative.
The reason I did not is because my restriction, when I wrote my restriction here, it's x times x plus 2 cannot equal 0. If that cannot equal 0 had been an inequality, which it's not in this case, if it was like this, then I would have to do test values, because there's an x squared and an inequality at the same time. Does that make sense? Okay. All right. Questions before I move on to 63?
62. Yeah, can you 62?
62 first. Okay. Yes. 62. h of x equals 10 over x squared minus 2x. I am going to start this one off for you guys, but I'll let you finish it. I need all of you paying attention. It's a fraction. There's no square roots anywhere. What is my only restriction? The denominator cannot equal what? Is this one where I have to do test values? Yes or no? No. There's a degree of 2, but it's not an inequality. It's a cannot equal, so this is not a test value problem. No, because you do factor and solve. How do I factor this? So what are my two cannot equals, my two restrictions? Not 0 and not 2. And then you graph it and write it interval notation. You do not have to graph it. If you can do interval notation just by looking at this, that is fine. Does anybody want me to graph it?
You can if you want.
I can if I want to. Okay, bless you. So if it can equal those two numbers, what does it mean about everything else? Shaded, outside, middle, right side, and those two are the open. So it's going to look very similar to this one up here. Negative infinity to 0, union 0 to 2, union 2 to infinity with parentheses. Yes?
We have to answer like what parts are going to be shaded on this.
Or it could just all be an implementation.
You don't have to give me this on the test. You will have to give me that.
Okay. Yeah.
This is optional if it helps you.
Okay.
If it helps you figure out what numbers go where. Because some kids will like flip-flop the negative 2 and the 0. But if you put on a number line, it's really clear and easy to see. So this would be in your workspace if you need it. This would be in your answer. This for sure would be in your workspace. This stuff for sure would be in your workspace. The graphing is optional. But this would be in your answer column, that kind of answer. All right, are we ready for 63? Okay, 63, like number 60, is another one that's missed quite often on the test. So please make sure you are paying attention. G of y equals y plus 2 over the square root of y minus 10. Do you guys agree? Okay. First, look at the top. Does the top have any restrictions with y plus 2? No, we don't have to worry about the numerator if there's no restrictions up there. There's two restrictions going on here. The first one is the denominator cannot equal what? 0. The other one is the square root, which states that the inside has to be what? Positive. And how do we write that with an inequality? Greater than or equal to 0. Do you agree both of these are going on? The inside has to be greater than or equal to 0, but the denominator cannot equal 0. How do we put these two together? The inside has to be not greater than or equal to, just greater than 0. Okay, so y. With a regular square root, if I were to plug in 10 minus 10 and square root of 0, ignore the fraction. Am I allowed to take the square root of 0? Yes or no? Yes. Then why did I take off the equal bar? Because it's in the bottom of a fraction. And can the bottom of your fraction be 0? No. So if you have a square root in your denominator, it's not just a regular fraction, it's a square root. You have two things going on. You drop the equal bar. It cannot be equal to 0 any longer because it's in the denominator of the fraction. So y minus 10 is greater than 0. Do I have to do test values here? There's an inequality, but what's the degree? The degree is 1. Do I have to do test values? No, I just add the 10. Y is greater than what? 10. So how would you write that? 10 comma infinity. And what would be on the 10? Parentheses or brackets? Parentheses. Now, say this is a test question, and it's multiple choice. Do you think one of the multiple choice answers would look like this?
Yes.
Yes, and that's probably the most common wrong answer I get. Kids are like, oh, greater than or equal to 0, and they solve it, put the brackets, and it's wrong. Why? Because that's including 10, and can you plug 10 into this function? No, you can take the square root of 0 all day long, but 0 cannot be in the denominator of the fraction. Does that make sense? Okay, are we ready for the next one?
Yes.
Okay, 64. The test question is going to look more like 63 than it does 64, but 64 is very similar to the last one. It doesn't look like it, but I'll show you why it is. Okay, looking at the inside, is that the same as that? X plus 6 the same as 6 plus x. Now, because those two are exactly the same, it ends up being very similar to the one we just did. Okay, I'm going to look at the bottom first. There's no square root there, so what would I say? 6 plus x, what? What's my restriction if it's in the denominator? Cannot equal 0. Okay, do you agree typically that would be all I do? Yes? And then I would say x cannot equal negative 6 and be good. But what do I have in the numerator that's typically usually not there? A square root. So according to this, I could pick anything except negative 6. So let's try negative 7. Would negative 7 work in this function? No. Would it work in the denominator? But would it work in the numerator? No, because negative 7 plus 6 is a negative, and I can't take the square root of a negative. So we have another restriction. X plus 6 has to be greater than or equal to 0. We're running into the same problem. X is greater than or equal to negative 6. According to this, it can equal negative 6. Can it equal negative 6? In the top it works, but does it work at the bottom? So how do we put together cannot equal 0 and has to be greater than or equal to 0? Just greater than 0. So x is greater than negative 6. Not greater than equal to, greater than negative 6. Why didn't I do test values on that one? There's an inequality. The power is 1. The degree is 1. If it's squared or higher is when you do the test values. Are we good?